Hello everyone. So in the last video of this series, we talked about collections and generics. Now in this video, we are going to talk about streams, lambdas, and function interfaces. So if you haven't watched the previous series or previous videos of this series, please take a look at all those videos. You will find a lot more information. Now in this video we are going to specifically talk about streams, lambdas and function interfaces. And before we do that, again, this I do every time in every video, but still I don't see a lot of you subscribing to my channel because I can see the analytics, so it's not happening, but it's a humble request, please do that. Now let's not waste any more time and kickstart this video. So now let's talk about streams and function interfaces. So the very first question is, how do map and flat map differ in Java streams? Give an example use case for each. So map method transforms each element of a stream or collection by applying a provided function. So this is a one-to-one mapping between input and output elements. Right, so here the transformation is happening individually and it always returns a single stream of transformation. So if you take a look at this example, here we have a list with 3 elements basically, and what we want is we want to transform each name to uppercase. So how do we do that? We have used map function here to convert each element to uppercase, and then we are collecting it back to list. Now talking about flat map, so this is used to flatten a stream of collections or nested data structure into a single stream. So this applies a mapping function along the way, and this is typically a one-to-many transformation. Like map is one-to-one, but this is one-to-many. So it applies the provided function and flattens the resulting nested structure into a single stream. And it handles scenarios where each element can map to multiple output elements. Now taking a look here, so this is a nested collection, so this is a list of list, and here you see that we have names. Again, what we want is we just want to flatten it up, as in you just want to have a single list from a list of list, right? So that means that you have to flatten the collection. That is where you will use flat map. So I hope this is clear now. Now let's move on to the next question. Explain the difference between intermediate and terminal operations in a stream. So intermediate operations are lazy, and because of which we also say that streams are lazy. So intermediate operations transforms a stream into another stream. They do not perform any processing until a terminal operation is invoked. Alright, so this always returns a new stream, that is a must, and these are not executed immediately. Instead, they define a pipeline of transformations. So this can be chained together to build complex stream pipelines. So some of the examples are your filter, map, flat map. These are the intermediate operations. Now talking about terminal operations, so these trigger the execution of the stream pipeline. So they consume the stream and produce a result such as a collection or maybe a single value, right? So this does not produce a stream result, this produces a non-stream result, and this and the stream pipeline, no further operation can be performed on the stream. So this is actually performing actual processing of the data. So some of the examples are your collect, for each, reduce. These are your terminal operations. Now moving on to the next question, what is the difference between filter and find any or find first in streams? So filter method is an intermediate operation that processes all elements in a stream and retains only those that satisfy a given condition or a predicate, right? So if you take a look here, so here we have a list of integers, and here what we want is we want to find out the even numbers, as in you need to filter out the even numbers and leave the rest out. So based on this filter condition, everything that is going to satisfy is going to be collected and the rest are going to be left out. So here you have the output like 246. Now this is filter, and now we have to separate find operations. So we have find any and we have find first. So both of them are terminal operations. Okay, so that is the basic difference. Filter is intermediate and find any and find first are terminal. So find any means that you have to find any one element that matches the criteria without maintaining or guaranteeing any order. So this can be more efficient in parallel stream since it can terminate as soon as an element is found. So if you remember, in queries we used to have select star from this table, fetch first one row only. So here we are just fetching the one row, right? So this is something like that. So if you take a look at this example, here we have a list of integer. Again, we are trying to find out the even numbers here. But if you see here, what we are doing is we are also using find any. So it means that the very first element, whatever it is, once we are able to find that out, then the stream is ended, as in it is terminated, and that output is going to be displayed in the sysout. All right. Now find first is a bit different. So it finds the first element that matches the criteria, maintaining the order of the stream. So in find any, we don't care about the order, but in find first, we maintain the order of the stream. So this is very useful for sequential stream where order matters. So the example is pretty much same, but the output also is going to be same, right? Alright, moving on. How do you handle checked exceptions within Java 8 streams or Lambda? So the very first way is to wrap checked exception into runtime exception. So this means that you have to convert checked exception into unchecked exception, like your runtime exception, to bypass the limitation. So the reason is that handling exception in streams or lambdas can be challenging because function interface like consumer, function or predicate do not allow checked exception in their apply, accept or test methods. So that is why you need to wrap your checked exception into runtime exception. So this is very straightforward and simple to implement, but the disadvantage is that it loses the original checked exception type. So if you take a look at this example, what we are doing is we are trying to parse the integer because they are currently in a string format, right? So once we see any kind of error which is going to be a number format exception, basically in that case what you're doing is you are throwing the runtime exception. You are not actually handling it as a checked exception, and that is how you make it work. The second way is that you can use a wrapper method which is going to handle the exception for you. So this converts checked exception to unchecked ones. That is the disadvantage, but the pro is that this is much cleaner and reusable for multiple function interface. So if you take a look at this code, we have a wrapper class for us which is lambda utils, where we have a wrap function which is going to take care of the exception handling for us, and then we have a function interface with us. So this is actually throwing the exception. So this is going to be a bit complex, but it's not like you have to use it for every interface, right? So this is never going to be a good scenario in that case, but things like this do not happen very frequently, so you don't have to actually do it. But yeah, this is also one of the way to handle it. Now you can also use optional to handle exceptions gracefully. So we have optional class with us. So what you can do is you can check first if something is going wrong or not. In that case, you can catch the number format exception and try to return empty. So in this case, we are not actually throwing the runtime exception, rather you are handling it. So it handles exception without stopping the entire stream pipeline, and it also allows you to log or handle the failure cases. So if you take a look at the example here, we are just handling it using optional class, and the only difference which you see here is that the return statement is here. So this actually does not kill your stream. But the disadvantage here is that it introduces additional wrapping and unwrapping of optional. So yeah, that is there. Now the best case scenario that I would say is that just use logging. So as a developer, I use this. So if you want to handle exception without actually halting the application, in that case what you should do is proper logging, right? That's it. So if you take a look at this code, what I'm doing is if something goes wrong, if we have a number format exception, in that case I'm just simply logging the exception and returning null. I'm not breaking the flow, I'm just going out of this method so that the rest of the application is going to work perfectly fine. That's it. So here the only disadvantage is that non-null checks might clutter the pipeline. That's it, but it's not going to be a major thing. All right, so yeah, now let's move on to the next question. How do streams handle large data set efficiently? So streams are basically designed to handle large data sets. That is why we have streams in Java 8, right? So the major thing that I can think of right now is your lazy evaluation, because streams are always lazy. Means that your intermediate operations are only executed when a terminal operation is invoked. So how it is going to help you? So it is going to avoid processing all elements if it is unnecessary. For example, with operations like find first or limit, only the required number of elements is processed. So this is going to reduce memory and CPU usage by processing elements on demand. Now we have streams pipeline. So streams allow operation to be chained into a pipeline. So each element flows through the pipeline, being processed by one operation at a time before moving to the next. So it prevents creating intermediate data structure for each operation. Also it reduces memory overhead by avoiding temporary collections. Now we have parallel streams also. So parallel streams were actually beneficial when you have a larger data set that you want to compute parallelly. So you can use parallel stream, and this is going to split the larger data set into chunks and process each one of the chunks simultaneously on multiple threads. So here we are utilizing the multi-core of your system basically. So if you have a 8-core CPU, 16-core CPU, in that case all core are going to be utilized by all the threads. So if you have 16 core, that means that 16 threads are going to be utilized to run a single thing. Now moving on to the next question, explain the types of method references in Java. So this is again a new feature with Java 8. So what is a method reference? So this is a shorthand for writing Lambda expression to call a specific method. That's it. So this improves code readability and simplicity, and there are four types basically of method references. So first is reference to a static method. Then you can reference to an instance method of a particular object. You can reference to an instance method of an arbitrary object of a particular type. Then you can reference to a constructor. So yeah, these four types, and you can see the code example here of each. So this is the example for static method. So here you can see that we have class name, integer, and then parseInt. So this is reference to a static method. Now in the second example here we have message length, which is the reference to an instance method of a particular object. So in your string class you have length method, right? So that is how you operate on it. Then you have here system.out.println. So here you don't call. So this is not actually going to help you out in any case. So I would say use system.out.println, but this is just an example of how you can reference to an instance method of an arbitrary object of a particular type. So here out is an object, right? Now reference to a constructor. So yeah, this is something good that I actually use. So if you have to use a new object, you use string : new. So yeah, that is reference to a constructor. All right, now let's move on to the next question. Can Lambda expressions capture local variables? What are the rules for capturing local variables? So the answer is yes, they can handle or capture local variables. So what you can do is basically, let's say that in this example, if you have int x equals to 10, so this is effectively final, right? So if you use runnable r equals to, and then you try to print out the value of x, then yeah, it is going to work. So it will print out 10. The Lambda expression can access final local variables, so variables explicitly marked as final, and effectively final variables that are not marked as final but whose value is not modified after initialization. So yeah, this is how you capture local variables. Now there are certain rules for capturing variables. So first rule is that you have to use final. So a variable is considered effectively final if it is assigned a value only once and is not modified thereafter. So if the variable's value is changed after being captured, the compiler throws an error. So here if you take a look, this is one of the example where you will see a compilation error. Alright, now let's move on to the next one. Explain how predicate function and supplier differs in terms of purpose and usage. So these are the function interfaces that got introduced in Java 8. Now talking about what is the major difference is basically in the usage. So predicate represents a Boolean valued function. So this is either a condition or a test, right? So it provides you a method test where it expects a return type Boolean. In function, this represents a function that accepts one argument and produces a result. So here we have a method apply. So the purpose here is to transform or map a value of one type to another. Now we have supplier, which represents a function that supplies a value without accepting any input. So in function you were accepting an argument, but here you don't expect any argument. So this is used to generate or supply values without requiring any arguments. So let's take a look at the examples. So this is your predicate, and here you can see that we have is even condition here. So when you use test here, so it prints out either it is even or it is odd, right? So that is how you use it. Now in function you have to provide an argument. So here what we are doing is we are providing apply, and then we are using apply method and then providing argument hello. So here what we are doing is we are trying to print out the length of that string. Now in supplier, basically you don't give any argument, you have a get method. So here you just get the value. So here we are printing hello world. So just to summarize, predicate is about testing conditions, function is about transforming data, and supplier is about providing data without input. Alright, now let's move on to next. How would you handle exception in function interfaces? So we have already talked about this. So function interfaces are actually not meant for handling checked exception, and we have already covered this topic. So let's move ahead with the next question. What is the purpose of split iterator interface? How it is used in stream processing? So this is again a new functionality in Java 8, and this is used for traversing or partitioning elements of a data source, such as a collection or an array, in parallel or sequential manner. So we used to have a regular iterator. Now split iterator is your iterator, plus it can divide elements into smaller parts which can be processed in parallel. So that is added functionality. Now how it is used in stream processing? So if you take a look at this example, so here we have a string array basically, and here what we are doing is we are trying to use a split iterator on it. So if you try to print each element, so you can use try advance to process each element. So when you use try advance on it for the very first time, you got output Alice, and then you got output Bob. So this is sequential traversal, right? Now for parallelism you can do, so here you are splitting the collection, and how you are doing it is you are using try split method. Now we are processing elements in the first split iterator, and then we are processing elements in the second split iterator. So what we are doing is we are using for each remaining method. So here in the first split iterator you got Alice and Bob, in the second one it got Charlie and Diana. So this is not going to be beneficial if you work on a smaller data set. So if you have a larger data set that requires parallelism, then you should use split iterator. And let's say if you are developing custom data structures that require stream-like operation, then also you can use split iterator. Alright, now let's move on to the next question. How would you implement a custom function interface? What constraints must it follow? So these are this is one of the basic questions. So for a function interface, you just need a simple abstract method. That's it. You can have default and static methods, which were new features with Java 8 again. Now the annotation, function interface annotation, is actually optional. You can use it. If you decide not to use it, then it's okay as well. Now moving on to the next question. What is the difference between stateful and stateless intermediate operation in streams? Provide examples of each. So stateless intermediate operation are operations that process each element of the stream independently of other elements. So they do not require maintaining any additional state information, and they do not depend on the size of the stream or the order of elements. So examples are your map, flat map, right? Filter. Now stateful intermediate operations. So operations that need to maintain some state or context to produce result. So they depend on the whole stream or the order of elements. they may need to buffer or store elements temporarily. So these are less efficient for parallel processing as they may require synchronization or order preservation. So examples are your limit, distinct, sorted, right? Alright, so now let's talk about lambdas and default methods. So we have roughly talked about it, but let's talk about more advanced topic. So the first topic is, how do default methods work in interfaces? Why were they introduced in Java 8? So as we already know, these are some of the new functionality added in Java 8. Along with this, we also got static methods in interface. So default methods provide you a new functionality to interfaces without breaking existing implementations. So a default method is a method in an interface that has a default implementation and you use it using default keyword. So why do we need to use it? The obvious answer is backward compatibility. So this allows adding new methods to interfaces without forcing all implementing classes to provide an implementation. So this ensures that the existing code that implements the interface does not break. Now this does not mean that you can only have default methods. So this is an additional functionality which you can use alongside your abstract methods. Now this is going to make it easier to evolve APIs like your Java collection framework by adding methods with default behavior. So here the keyword that you should use every time when you hear default methods, use backward compatibility. Now let's move on to the next question. What is the use of function interfaces like predicate, supplier and consumer? So we have already talked about predicate and supplier before, but consumer we haven't talked about, so let's talk about it. So again, these interfaces are your function interfaces which got introduced in Java 8 and the purpose is different. So predicate, so you should use predicate when you want to represent a condition, or a predicate which means your boolean based function that takes one argument and returns a boolean. So here we have a test method and the use case is that you should use it for filtering, validation or matching. So supplier represents a supplier of results. So it does not take any arguments but return a value. So here you use get method and the use case is that you should use it for lazy evaluation or factory methods, or let's say supplying default values, right? Now consumer here is different. So this represents an operation that takes a single argument and performs some action, but this does not return a result. So here you have a method except. The use case is that you should use it for performing operations like printing, logging or modifying objects, because you don't return a result. Alright, now let's move on to the next question. What are the key components of a lambda expression? How do they map to functional interfaces? So let's take an example here because you need to see before we can explain. So if you take a look at the example here, you see that the first is that you are using int x int y and the result is x plus y. Then again you can do x comma y, which means again you don't specify the data type, but again it is going to do x plus y. And there is an option that you can do it without parameters. So this is just an example. So here the key component is your so first component is your parameter list. So here on the left hand side you will have parameter list. So this specifies the input parameters for the lambda expression. So these are basically enclosed in parentheses and these can be omitted if there are no parameters. So just leave it out. Now types can be explicitly stated or inferred from the context, right? So it is optional. Now the second component here is your arrow token. So this separates the left hand side and the right hand side here. So this is just to separate the parameter list from the body of the lambda expression, right? Now the third major component is your body. So the logic or the main code to be executed by the lambda that you put up in the body, which is your right hand side. So this can be a single expression or a block of code enclosed in your curly brackets. Now single expression do not need a return type or braces, but multiple statements do require braces and an explicit return statement. So if you take a look here, we have a block of code. So here we have a return statement. Now the second question, how do Lambda expressions map to function interface? So they map directly to function interface because a Lambda expression represents the implementation of a single abstract method in a function interface, right? So let's say if you have a function interface like this, so we have a calculator interface where we have a calculate method, simple. Now the Lambda expression implementation is going to be like this. Here you have addition happening on A and B, and you have to provide the values A and B. So here you will see the output as 8. So yeah, this is how it works. So the parameters of the Lambda expression correspond to the parameters of the abstract method in the function interface. Here the parameter types can be inferred from the context. The body of the Lambda expression provides the logic for the abstract method, and it can be a single expression or a block of statement that we have already talked about. Now you can use default and static methods as well because function interface can have it, but they do not interfere with the mapping of Lambda expression to the single abstract method. Now moving on to the next question, explain how this keyword behaves differently in a Lambda expression compared to an anonymous class. So in a Lambda expression, this keyword refers to the enclosing instance where the Lambda expression is defined. So a Lambda expression does not create a new scope or instance. It is treated as part of the surrounding class. So if you take a look at this example here, this .name refers to the name field of the enclosing Lambda example class, not a separate instance. All right. Now talking about this in anonymous class, so this keyword refers to the instance of the anonymous class itself, not the enclosing class. So anonymous classes create a new scope and a new instance. So here if you take a look at the example, here this .name refers to the name field inside the anonymous class and not the name field of the enclosing anonymous class example class. All right, now let's move on. How do you override a default method in a class that implements an interface? So this is the basic example of how you basically use default method, and here you need to override. So here we need to take some steps. First is that you need to implement the interface, which we have already done. So the class implements the interface that contains the default method. First step, right? Second step, you need to provide a custom implementation. So you can use the override annotation to define a new implementation for the default method in the class. Third step, which is optional, you need to call the default implementation. If needed, you can call the interface default method using interface name dot super and then dot method name. All right, not a major thing, simple as that. Now let's move on to the next question. What happens if a class implements two interfaces that have the same default method? How do you resolve this conflict? So this is a very tricky question which I have asked whenever someone tells me that you can use interface to implement multiple inheritance. So if a class implements two interfaces that define the same default method, the compiler generates an ambiguity error because it cannot decide which default implementation to inherit. So in this, the class must explicitly provide the conflicting method and provides its own implementation to resolve the conflict. So here if you take a look at this example, here we have two interfaces with the same method greet. Now the class has to specify that which greet method does it want to override. So here we have implemented interface A and interface B, but we have the method greet. So if you don't override the method, then in that case you will see an ambiguity error. So that is a must, you need to override it. So that is why here in this example we have an overridden method where we have provided the functionality. So when you do call it, you will get this functionality. Alright, now let's move on to the next question. Can a default method call another method in the same interface? Provide an example. Yes, it can do that. So let's take an example. So here if you see that we have an interface greeting and we have default method say hello. But if you take a look here, we are calling ask question, which is again a default method. So we can do that, right? So a default method can call other default methods in the interface, abstract methods declared in the interface, and the static methods in the interface. So all sort of methods. Alright, now let's move on to the last question. What are the limitations of using default methods to extend interfaces compared to inheritance in classes? So default methods in interfaces offered a way to provide concrete behavior in interface, but they come with several limitations compared to class inheritance. So first is that you cannot access instance variables. So interfaces cannot have instance variables, right? And default methods can only work with static constant or parameters passed to the method. Also, classes can define and use instance variables, providing more flexibility for maintaining state. So that is the first difference. Now second is that you don't have any constructor support, so interfaces cannot define constructor. This limits the ability to initialize default state or perform setup task. But in class inheritance, classes can define constructors to initialize state and perform setup for subclasses. Now third is that you cannot use super to access parent class behavior. So default methods cannot use super to call methods from a parent interface. However, they can use interface name.super.method name for disambiguation. Now in class inheritance, subclasses can use super to directly call overridden methods in parent classes. Now I can go on and on. There are a lot of limitations, but I think these three cleared the stuff. So in default methods in interfaces, you don't have support of instance variable, constructor, and deep hierarchies. But in class inheritance, you get fully supported instance variable, constructors, and deep hierarchies. Now there are some limited support towards super keyword and final private methods in default method, but in class inheritance you get full support for super keyword and final private methods. So these are some of the difference. So this was it for this video. In the next one we are going to talk about Spring Boot, which is a hot topic as of now. So stay tuned for that video, for which you again have to subscribe. And if you have any questions related to this video or any other topic, do let me know in the comment section of this video, and I will meet you in some another video. Till then, stay happy, keep learning, and bye bye.